So today we're working on problems using systems. And this is off of the study guide, page 43. First problem for today is this one, which you guys have. Tickets for the senior prom were $25 for a single and $40 for a couple. We're just talking about tickets here. The amount of money was $3,800, and the total number of tickets was 110. Using the things we know about the story, we can figure out how many of each type of ticket were sold. And here's how it looks. Starting off, we know that the cost per ticket is $3,800 total worth of revenue. And we know that the total number of tickets, that is the combined tickets of singles and couples, was that many. Using the linear combination method and multiplying the second equation by -25, we are able to cancel out our S variable, and we end up with 15C is 1050, and finding that C's value is 70. Solving for S, we end up with 40. To test that, we can take the 70 and 40 numbers and plug them back into that original equation here, and we end up finding that we are correct. With that same information, we can actually ascertain another question. Maybe we want to know how many people were actually there. How many people were actually there? So if there are 40 singles, that's 40 people. 70 couples, that's 140. Altogether, you get that. The second item, a cashier had to give $3.45 and change, but only had quarters and dimes. She had 15 coins, or she was given 15 coins. How many dimes were received? So another similar type of scenario, knowing that we can ascertain dollar amount, 25 cents per quarter, 10 cents per dime, is that much. Notice I eliminated the decimals, just cleans it up a little. And we know that the total number of coins, quarters, and dimes altogether was that. Using the linear combination, I'm going to cancel out my D's by multiplying the second equation by -10. Solving for Q gives me quarters. The remaining 2 coins are dimes. Plugging in those values into the first equation, this one, brings me back to another check, which is true. We end up being correct. Number 3 has to do with speed and tailwinds and headwinds. We talked about those definitions, and you can see those on page 43. But to make sure we're clear on it, remember that a tailwind blows from behind, whereas a headwind pushes against you. A tailwind blows from behind and a headwind pushes against you. And that has an effect on your speed. And if you look at their sample, they show us that when you're being helped by a tailwind, it makes your speed, P, be faster. When you're being blown against by a wind, it kind of is going to slow you down. It's going to remove some of that speed. So here's 3. With a headwind, the plane traveled this and that amount of speed, that amount of time. So rate times time equals distance, and this is with a headwind. So headwind, P minus W, 2 hours, 2P minus W. With a tailwind, it was shorter, 1 hour, 45 minutes, which is 1 3/4. So we're going to fraction that. 7/4. 7/4 P plus W. Find the plane's airspeed and wind speed. Well, got it started here. With the tailwind, that's the helpful wind pushing you along. Battling that headwind. Going from there. These items, remember, are equal to 840 miles. But we're going to divide out our 7/4 and 2s respectively, shrinking these numbers. So the P plus W number becomes that, and the P minus W number becomes that. Added together, you end up with 2P being equal to the sum of these two things, which is 900. Cut in half, you should have 450, which we're going to plug back into either one of these things. 450 plus W is 480, so W is 30, wind speed. Even if you plug it into the other one, 450 minus W, 420, you would find out after solving it that the wind is 30. So the plane speed is 450, the wind is 30. And we can take all of these answers actually and plug them back in to that original scenario, which was this or this if we wanted to, and you would find that you were correct. Last one, number 3, or number 4. With a tailwind, a small plane traveled 420 miles in 1 hour, 30 minutes. So tailwinds is the P plus W rate. In 1.5 hours. The return trip against the same wind, so now we have a headwind. Slows us down a little bit. It's going to make us take longer. Return trip took 30 minutes longer, so now it's 2 hours. Find the wind speed and the airspeed. So we got our 420 miles. These are the things that equal 420. 3 halves, P plus W is 420, as does 2 P minus W. Multiplying by your reciprocal here and here, and you end up with P added to W being equal to, divide that out, 280. And this one, dividing it in half, P minus W is equal to 210. And combine. Lucky for you, you don't have to do anything because you've already got an opposite. 2P is equal to 490. Cutting that in half is going to give us P. $245, it looks like, is the P. Now you might be thinking, well, that seems slow. The other planes were going in the 400s or 500s, I believe. Well, think about it. This is a small plane, so it's not going to have the same power as a jet. Plugging in the plane, maybe here, we can do 245 added to W. And subtracting 245 from 280, you should get 35 as your wind speed. You can plug it in the other one too if we wanted. 245 minus W is 210. How am I getting this different here? Something is missed. No, it's not. Wait. You've got 35 here as well. Okay. You could have also plugged in this data up here in the original bigger equations and you would have found it out. So plane is 245, that's the plane speed, and the wind is 35.